So now you're asking yourself, well, how did you do this? How are you going to gather this information? So I designed a mixed method. I took on a mixed method approach. What that means is I wanted numbers and I wanted words. I wanted qualitative data and quantitative data. And the reason for this, we're saying it very simply at the moment, the reason for this is because I wanted multiple sources of data. I didn't just want numbers and I didn't just want the words. I wanted to be able to take from students different ways of collecting information off them to bring all of this together to really study this thoroughly. So the first thing I did, I had a 3-phase design, and again, this is going to be on your handout. So in the first aspect of it was I compared cohorts. And if you look at the second page, there's a lovely in-depth table for those of you who are lucky enough to have a handout. And what you'll see here is that in the first phase, I was doing a comparison of graduating students. I took students graduating from the old science curriculum and students graduating from the new science curriculum. And I captured them in their final year, right before they were going to graduate. And I wanted to understand a couple of questions. So in phase 1, what are graduating students' perceptions of quantitative skills in the curriculum? And how do these perceptions change the implementation of the quantitative skills intended curriculum? So how did this change from old to new? In the process of doing this, I created a purpose-built exit survey to gauge this from the students. I administered it online, and I sampled to get students who had been in the science curriculum, eliminating transfer students or students who happen to be doing dual degrees. In the second phase of my research, I did an analysis of the quantitative skill level or performance of students within that new curriculum. Because now I wanted to know, they've got beliefs and perceptions, and my survey has captured that. But within that cohort of students graduating from the new curriculum, what can they actually do? Can they do quantitative tasks in the context of science? So for this part, I developed a purpose-built assessment task based off of the work of a couple of researchers out of the United States. Again, the references are actually in the handout as well for that. So now I'm trying to get at what can they do, their performance levels within this new group. But part of the mixed methods design, so now I've got all this quantitative data, is that within that cohort of the students taking the task in the new one, I also picked a subset of 13 students. And I followed them as they went from first year to second year to third year. And I interviewed them and I gathered data because I wanted to understand their stories. As they went from first year to second year, what changed? What attitudes and beliefs did they actually bring in? When they left, when they graduated, how did these things change? And the notion of doing this was just to try to shed some light on the numbers that I was collecting. So being able to bring all these different types of data together. So I want to talk a little bit more about each phase of the data and give you some initial results. I'm going to do this with the caveat of saying I haven't finished analyzing these results. Some of them have been published, the majority of them have not yet. So I'm just going to give you a little bit of a taste so that one day when I talk about my results, you all come back and listen again. So the first phase, the survey that I administered to students across 2008, 2009, and 2010 cohorts, so the old and the new. On that survey, I asked students about typical demographic data they would collect, but I also asked them about any experiences they had with undergraduate research, any work they had done in any labs, summer research scholarships, and then I also asked about their career aspirations. So when they graduated, where were they hoping to go? So then I dug down and wanted to get their attitudes and beliefs about quantitative skills. In particular, I wanted to look at how the whole experience, the whole science program of 3 years had influenced them. So I asked them to talk to me about how important they thought quantitative skills were. I asked them to tell me how much they were actually included in the curriculum. I wanted to know if they felt they'd actually made improvements as a result of studying science in their quantitative skills. And then I asked about their confidence levels. Initial results of this when I compared the 2008 and 2009 cohorts. So these are two cohorts that graduated from the old one. I was pleased to find that there were no statistically significant differences in the responses students were giving to these questions. This is good, but it's not surprising because they were going through a similar curriculum. But what I also found when I did a regression model to try to understand what factors were influencing those students who were giving themselves higher quantitative skills self-rating. And what I found, it was the variables of how much they felt quantitative skills had been included, so how many courses they had taken that actually required them to utilize their quantitative skills. And I also found that it was how confident they felt as well. Those were two variables that were contributing to having increased levels of quantitative skills. Again, this is the old curriculum. What I also found then, because I asked them, well, tell me when are these quantitative experiences that you're having? Are they happening in the tutorials? Are they happening in your lectures? Are they happening in your practicals? Probably unsurprising to you, it's in the practicals, where their students were really having to apply and utilize these skills, much more so than in the lectures or in tutorials. Then when it came to, I asked them, was it first year courses? Tell me what courses at what year levels actually required you to utilize these skills. So again, these are students self-reporting. And what I found here is that it was largely first year. Then there was a statistically significant difference going into the second year, and then more of a decline going into the third year. So a lot of the experiences they remember being asked to use was at the first year level, not the third year level. And then finally, I found that there was an association that undergraduate research experiences were also playing a role in those students who were reporting higher level of quantitative self-confidence, self-rating. So the next phase of the study, when I actually looked at within the cohort of students graduating from the new science curriculum, what can they actually do quantitatively? I developed the task that I told you about. Students were given a lot of information, and really they just had to reason. And I did this, was broken down, and there was a section I called mathematics. It's a really foundational kind of numeracy type of questions that they were asked. Nothing overly sophisticated, actually. And then we also looked at statistics, and the statistics went from basic statistical concepts to more complex statistical concepts. As well, because this is a low stakes assessment task, the students were not getting a grade for this. So you question, well, why would you actually try? I also used an indicator of how much effort students were putting into this to gauge who was actually trying versus who was just filling it in because it was in front of them. So again, I'm going to just give you a glimpse into some of these results. I've been completely raw, it hasn't been filtered, but just to give you some notion of what we found here. When it came to the basic foundational kind of numeric principles that I was looking at, metric conversions, can the students pipette, dilutions, and also looking at logarithmic functions, roughly 60% of the students were successful in carrying out metric conversions and logarithmic functions. The good news is over 90% could work out the pipetting. That was the best result. When it came to the statistics, what the results are initially indicating are that the students are leaving with fundamental misconceptions around inferential ideas. So there, sampling, the difference between sampling and error, sampling standard deviation, really was finding students. In some cases, less than 10% of the students were actually leaving with the appropriate understanding of some of these concepts. When it came to more foundational statistics, what we discovered, or what I discovered when you look at the data, is students are still struggling with the notions of variance, standard deviation, as well upon graduation. But again, I caution you, it's raw data, I haven't filtered it, I still have more analysis to do there, but just the initial results are indicating this. I can also say that by comparison of similar types of questions that were given in the United States, it doesn't appear that these results are that far off from that as well. Some of the big concepts we've identified are fundamentally challenging concepts that students So in the final phase, the longitudinal phase, I started off with 14 students. After the first year, one of the students dropped off, so 13 students completed the study. And what I did there was just interview them, collected data both in face-to-face but also in online mode at 4 time points across their 3 years of their science degree. And from there, what we really talked about was just their quantitative experiences. Where were they being needed? What did they think about it? How much were they utilized? Some examples of what you've been doing and what you've been looking at. And those students were selected for their sort of heuristic values. I wanted some diversity there, so mature age students, school leavers, students who had prior degrees, students who had absolutely minimal background in science as well. So that was a selected sample there. So we've got these 3 strands of data, these 3 phases of research. Students' beliefs from the survey, what can they actually do if they're graduating from the new science curriculum, and then the stories of these students as they travel through this. To bring all of this together, I'm going to analyze the results within the context of Snyder's notion of the hidden curriculum. And again, you've got this out in your handout. The Snyder's notion of the hidden curriculum, which he wrote about from research he did in the 60s, he was a dean at MIT, is the notion of how students in universities struggle with the tensions and contradictions of what's said versus what's unsaid. So for instance, come into university, you're a science student, you should be creative, you need to think for yourself, independent learner, do these things, this is what you'll be rewarded for. And then students do the assessment. And the assessment contradicts that. It actually doesn't reward those things that they've been told. So how do they rectify those tensions? So I'm going to apply that notion to the concept of mathematics and science. To dig that out a bit, I'm going to use a model used by Barnett and Coates out of the UK. And what they talk about are 3 notions of how we should think about curriculum: acting, knowing, and being. And these are 3 overlapping notions.